Hey guys, welcome back. For today's video tutorial, I'm gonna work on a new sensor that is L3G4200D. Now, to gain more knowledge about the sensor, how it works, what are the specifications for this sensor, let's have a look over the website for that, and it's controleverything.com, and here we go for the sensor. And let's see what we got for the sensor. So L3G4200D is a motion sensor, ultra stable 3-axis gyroscope. So these are some of its features. As you can see, it's a gyro at full scale range is plus minus 250 to plus minus 2000 degrees per second. Sensitivity is good, it's precise. As you can see, it's a highly stable over the temperature and the time, and you can also purchase the sensor from this very site. Well, for today's video tutorial, I will be interfacing the sensor L3G4200D with a Raspberry Pi and a Java code. Now, for the Java code, go to the source tab, and here comes the Java code sample. Now, you can also have the code as a zip file from here. You can download it, and you can also download the code from github.com. The repository there is Control Everything Community. Now, what we require is some hardware, some products, so that we can set it up, our connection, and make it work. Let's have a look over that. This here is our sensor, that is L3G4200D. Now, next we require is a Raspberry Pi, which you are able to see on my screen, and these are the GPI pins of the Raspberry Pi. Now, this here is an I2C shield. The reason why we are using this I2C shield is to make connections with other I2C devices among the sensor and the Raspberry Pi, and these connections should be made a lot easier. So that's why we are using it. So make this connection and gently place the I2C shield over the GPI pins of the Raspberry Pi. Now let me tell you that this I2C shield is also available on the website controleverything.com as a plus. So now we want to make a connection among the sensor and the shield, and here comes a connecting cable. Make this connection among the sensor and the cable, and while making this connection, make sure that the ground terminal of the sensor should be connected to the brown wire of the cable, and similarly this has to be processed for I2C shield. Now we need to power up a Raspberry Pi, and here comes a micro USB cable into the picture. Now gently put it over the power jack. Finally, we need an internet connection. There are two ways to make it done, and first of all, an Ethernet cable. As you can see, just insert it over the power jack. Now, in case if we don't have the first thing, we can also use a wireless Wi-Fi adapter, nano adapter, precisely to make this connection work. So it might save you a day also. So what we require, so we are done with that. All the connections we need, they are on the screen. Now what we require is a code, so that we can interface our Raspberry Pi and the sensor with that. So let's have a look over that. Now what we require is our Java code, so that we can interface our sensor with the Raspberry Pi and show the working. So for that, first of all, go to the website github.com, and here we have to search for the repository of controleverything.com, that is Control Everything Community. Now get over it, and here search for the sensor L3G4200D, and here we go. And this is the Java code we are looking forward to explore. Before going forward, let's have a look over the instructions we need to follow for this particular code. We have to download and install Pi4j library on the Raspberry Pi, and the steps are being provided on this very link, pi4j.com install. So let's have a look over this website, so that we can have a deliberate attempt to install this. And as you can see, it's a easy preferred installation steps, commands being provided, every relevant information being clearly instructed. So let's go through it carefully. Now this is the command to compile the Java code, and this is to run the Java code. Note it down and move forward. And here we are with the code. It's a .java extension file. Now first thing you notice in the code that we have imported some of the libraries which we have imported for the functionalities which we will use later on. Now public class L3G4200D is being created here, and the device address is bus.getDevice, and that's 0x68. Now in the writing section part, command sending part, we have enabled XYZ axis and disabled power down mode, and the address of the register is 0x20, command is 0x0f. Similarly, we have sent full scale range of plus minus 2000 degrees per second, Command for register is 0x23, command is 0x30. So after that we have to read 6 bytes of data for gyroscopic measurement x, y and z axis. As we are done with this data, we have to convert the values as you can see on my screen, which are according to the details being provided in the datasheet of L3G4200D. So at the very end of our code, we have the rotational x, y, z axis data on the screen. It's a raw value as you can see. Percentage D is the perfect format so that we can have the values down there. Now this is the generalized and the simplest code as you can see on the Java for the sensor L3G4200D. Now what we require is to interface, work out this code practically and show it. Let's have a look over. Now here comes the interesting part of this video, that's the practicality of this code. So for that, first of all, copy this entire Java code and go to the Raspberry Pi terminal. Here create a new file with the name of the sensor and .java extension, and here we go, paste the entire code, save it. Now this is the command to run the code as you can see, and it's a compilation process being processed. So we are done with the compilation. Now this is to run the code. As we can see, the values of rotational x, y, z axis are there. Now again, as you can see, there's a very minute change. So when I try to rotate it, there will be a huge change in the rotational x, y and z axis. It's perfectly going on, and the changes in the x, y, z axis for the rotation and so on. So this is the Java code working with the sensor L3G4200D along with the Raspberry Pi. Now what we require is to see the web benefits, the features and the applications of this particular sensor. We have just seen the hardware connections, the explanation and the working for the code for the L3G4200D. Now the L3G4200D is a low power 3-axis angular rate sensor able to provide unprecedented stability of 0 rate level and sensitivity over temperature and time. It includes a sensing element and IC interface capable of providing the measured angular rate to the external world through a digital interface I2C SPI. It has a full scale of plus minus 250, plus minus 500, plus minus 2000 DPS and is capable of measuring rates with a user-selectable bandwidth. Due to this, it is being included in a lot of applications like gaming and virtual reality, input devices, motion control with MMI, man-machine interface, GPS applications, and a lot. Well, the sensor can be purchased from the website as you can see on my screen from here, and you can also have the code from the resource tab. Now you can also have the code from GitHub repository, that is Control Everything community. In the end, I would like to make it clear that in case of any issue, you can have your queries on controleverything.com and you can post your comments on the community page. Now for blogs and articles, you can reach me on instructables.com, and to subscribe more video tutorials, go to our YouTube channel. Now I hope you enjoyed this video a lot and have a good one yourself. Thanks for watching.